Welcome back. In this lecture, we're going to talk about the basics of the object-oriented programming paradigm. And it doesn't feature too prominently in this camp, but it's worth noting. And as we get later on in the camp, hopefully you'll see why object-oriented programming has become so popular, why it's so useful. So, what are we going to learn? First of all, does it even make sense to think of software as an object? Well, we'll talk about how you can think about software as an object, and then talk about software classes or objects and how they're composed of things called attributes and methods. What do attributes do? What do methods do? How to distinguish between classes and objects? Pretty straightforward. Classes are the design, objects are the actual thing. How object-oriented programs work is a collection of interacting objects, and why it's such a useful thing. So first of all, let's just think about objects. Forget software. Think about an object. What is an object? You know, these kinds of definitions, it turns out, can be difficult. But here, I have a picture of an object. When we have an object, a physical object like this, we can say what it is, right? It's a stapler. We can say even what category or class it is. So it's not just a red stapler. It belongs to the class of staplers, right? There's all kinds of stapler designs out in the world, and this is one of them. So it belongs to that category or class of staplers. And then you can describe it. It's red. It's, I don't know, so many inches long, 6 inches long or something, 2.5 inches high. It's currently closed. It's currently facing towards you. You can describe it. That's description of what it is currently like is called its state. So in this case, the state, it has a X location, it has a Y location, it's closed, it has so many staples in it. That would be its state. And you can also modify its state. You can move it. That would change its X and Y location. You can staple something. That would reduce the number of staples it has. You can fill it up. That would increase the number of staples that it has. So basically what we have, an object is a thing that has state and can have its state modified. In terms of object-oriented software, the way we think of it is we say, okay, basically objects are things that they belong to a category or a class. They have state, and we have attributes that describe their state. So here my attributes, more or less randomly selected, X location, Y location. We could put direction that it's facing in there, number of staples. Is it closed? Is it jammed? What color is it? Those are all attributes that describe its state. And then we would have methods that change its state, like staple, refill, empty, open, close, clear, jam, move. These would be things that change the state of that stapler. And that's how all objects are. They belong to a class of things. They have attributes that describe their state. They have methods to change their state. So we're going to use those words a lot in this camp: class, attributes, and methods. And that's where those terms come from. They come from real-world objects. We're going to supply those to software objects. Here's another example: a chair. It's got a height, it's got location, a color, weight, it's got a status as to whether anybody's sitting in it or not. Those are attributes that would describe the state of the chair. And then we have methods to change the state. We can move it. We can sit, right? That would go from unoccupied to occupied. We can stand up. That would go from occupied to unoccupied, and so on. Some attributes in a real-world object are hard to change, like we probably can't change the weight of the chair or the material of the chair. You could probably paint the chair to change the color, but usually we think of a chair color as being fixed and unchangeable. Some attributes depend upon the object itself, like height. A lot of chairs, whatever height they are, that's the height. You can't change it. But some chairs have you can raise them up and lower them down. So you can change the height on those chairs. So when you're designing your software object, you have to think about, okay, what is it that I want to be able to change, and what is it that's going to stay the same? Here's another example, a car. It also has height, location, color, weight, occupied or unoccupied, or how many passengers are in it. Is it locked or unlocked? Is the engine on or off, right? All attributes that describe the current state of the car. And then we have methods to change it, right? Start, that changes the status to on. Accelerate, that changes the speed attribute. Fill her up, that changes the state of the fuel tank to full, so that the attribute that describes how much gas is in the car would go from, I don't know, empty to full, and so on. So, again, think of software objects the same way. They belong to a class of things, attributes to describe them, and methods that change their attributes. So here's a simple example. Let's play the sheepdog game. In the sheepdog game, you're a player and you're moving this dog around, and the goal is to get the sheep in the pen. So you can pause the video for a minute and think about objects. What kind of objects might be part of this game? And then once you think of the objects, what attributes might you have for them? What methods might you have for them? Well, for the sheepdog game, we probably need a sheep class. Right? That would be one category of objects. We would want a dog class. That would be another category of objects. And probably some terrain for them to play the game in. What attributes? Well, sheep. Let's see. X location, Y location. Current X speed, current Y speed, maybe their maximum speed. How would you change the state of the sheep? Well, the move method would move where they are, and it would move based on the speed. Maybe you have a vocalize method, where they bleat. Maybe you have speed up and slow down as methods to change the current speed. And the same for the dog. And it turns out that the sheep and the dog probably have all the same attributes and methods, or virtually all the same attributes and methods. And then for the terrain, you would want to know things like, how big is it? What's its width? What's its height? Where's the pen? What's the pen width and height? The terrain is pretty static. It doesn't really do anything, so you may not have any methods for the terrain. But this is an example of how you start to think through your software. Think through, okay, I need to have an object to do this, an object to do this, an object to do this, and then start thinking about the attributes and methods inside of the objects. So, the three types of objects, the sheep, the dog, and the terrain, these are what we're going to call classes. The class is the design, it's not the actual thing. For example, for the sheep, you'll notice I have 3 sheep in this game. I only need one sheep class because I can design the sheep one time. And once I have one sheep class, I can make as many sheep as I want. This is exactly like if you have the design for a physical object, a design for a hinge, for a door, and then you can make as many hinges from that design as you want. It's the same thing. We would have one sheep class, but then we would make 3 sheep objects from that class. So we distinguish a little bit between classes and objects. So the class is the design, and the object is what we call an instance of the design. The game has 1 sheep class, 3 sheep objects. The game has 1 dog class, and only 1 dog object. The terms class and object are often used interchangeably, but technically they do mean different things. The class is the design, the object is the actual thing. So when you're doing object-oriented programming, you design classes, and then you make objects from those classes. And we'll do that quite a bit throughout the camp. So hopefully by the end of the camp, you're comfortable with this. Now, why? Why would people do this? This seems like a very unnatural way to approach software production. But it turns out it's very useful. Why objects? First one, 3 big reasons. The first one is called data encapsulation. The idea is the attributes that are inside of an object, only that object can mess with that. So there's data inside of that object, only that object can mess with the data. And that's really the big winner here. It turns out prior to the object-oriented paradigm being developed, memory and data were being changed in ways that people couldn't control, and so you get a lot of control over who gets to play with your data. And this helps in software design. It helps reduce confusion. It helps reduce programming errors. It keeps the data safer. Very successful. The other thing that people were hoping to get out of the object-oriented paradigm was a lot of code reuse, where basically people would develop these objects, and instead of you writing a program, you just kind of went to a library and pulled a bunch of objects out and stitched them together, and that would be your program. That didn't work so well. But you're going to see that we do get some code reuse towards the end of the camp. And then the last thing that people hoped was software understanding. Software is definitely intrinsically hard to understand. It's an inherent problem, and people were hoping that by chunking the code up into these objects, you would have a better understanding of how the software was designed. It turns out that that didn't work so well at all. Nobody knows what what software design looks like anymore. In a complex piece of code, people still get easily confused about what the design is, what part of the code is doing what. It turns out that's just an inherently difficult problem with software. So, summary. Objects are things that belong to a class. They have attributes that describe their current state or the current situation, and they have methods to change that state. If you go back to that simple definition, it helps you clarify your software design. If you go back to that simple definition, then it becomes easier to think through, okay, how do I actually make software? Oh, I need to make a bunch of objects. I need to make a bunch of classes. Oh, for each class, what attribute should they have? What method should they have? And this helps you think through what you want your software to do. I'm not saying it's going to be easy. Getting good at software design still takes years of work. That's normal. But this is a good approach. It's been shown to be widely acceptable, and it's currently widely used throughout industry, research, amateurs, anybody who does coding. In the next lecture, we're going to start talking more about specific things for the camp, and specifically what all languages have to do, regardless of if they're object-oriented or not.